We're doing page 17. We're just going to do the odds. We're talking about the concept here of mutually exclusive. Mutually exclusive events mean that there's no event shared between the two. So if the event is in set A, then it is not in set B. So I think the best way to understand this is to look at some examples. So let's look at number 1. If we have a roll of a 6-sided dice, and A is the event roll the square number, and B be the event roll a factor of 6, are those mutually exclusive? Well, let's see if there's overlap. If there's no overlap, then they're mutually exclusive. So let's see, roll a square number. That would be 1, 4, and that's it, right? Roll a factor of 6. That would be 1, 2, 3, 6. So B would be 1, 2, 3, 6, and A would be 1 and 4. Is there overlap there? Yes. The 1 should be written in the middle. So if there is something written in the A intersect B space, which is this I-shaped thing, then they are not mutually exclusive. Okay, only if this area is empty could you say that that is mutually exclusive. So in this case, it is not mutually exclusive, right? Because there's something in that space. All right, let's look at number 3. Rolling a 6-sided dice. A would be the event roll a prime number, and B would be the event roll an even number. Prime number would be 1, 3, 1, 2, 3, 5, and then even number would be 2, 4, 6. So A would be 1, 2, 3, 5. B would be 2, 4, 6. Are any of those overlapping? Yes, 2. 2 overlaps. So that means they are not mutually exclusive. Right? Number 5. Here we're drawing out cards numbered from 3 to 10. A would be the event that a square number is chosen. So which ones are squares? That would be 4 and 9. Let B be the event an odd number is chosen. The odd numbers are 3, 5, 7, and 9. Now let's see if there's overlap there. A would be 4 and 9. B would be 3, 5, 7, and 9. The overlap would be 9, right? So yes, there's overlap, so they are not mutually exclusive. Okay, now let's look at the last one, 7. Each of the numbers 2, 3, 4, 5, 6, 7, 8, 9 are written on cards, put in a bag. Okay, A would be the event an even number is chosen. Even numbers here would be 2, 4, 6, and 8. And B would be the event a multiple of 3 is chosen, which would be 3, 6, 9. Now let's see if there's overlap here. 2, 4, 6, 8. Overlap with 3, 6, 9. Yep, there's an overlap of 6 there, so we should write the 6 in the middle, and that would mean that they are not mutually exclusive. Okay? I didn't tell you to do number 8, but just to show you an example where the two events are mutually exclusive, let's go through this one. So you toss 2 coins, and your possible outcomes are heads, 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 tails, tails, heads, and tails, tails. So let's see. A would be the event that 2 heads show. B would be the event that 1 head shows. Okay, so let's see. 2 heads shows would be the event heads, heads, and the event B would be the event that 1 head shows. That would be heads, tails, or tails, heads. Is there overlap there? No, there's not. So this area is empty, and outside there would be tails, tails, of course. And so are these mutually exclusive? Yes, mutually exclusive because there's no overlap. Okay, now we're going to talk about the concept of independence. when you have independent events, there is overlap between one event happening and the other event happening. And the way that there is overlap has to specifically obey a math rule, which is that if you take the probability of one event happening and you multiply it times the probability of another event happening, you will get the probability of both happening at the same time. And you've seen this before, although you may not remember. When you do chi-squared test, if you have independent events, yes, you can have overlap of the two events. But when you have the overlap, it's going to happen at the rate of probability of the first event times the probability of the second event. And the more it diverges from that amount, it is less independent. It is dependent. So the way the chi-squared works is it sees what you should get if it's independent, multiplies the two values together, and then it sees how far away the value is. If the value is very far away, then the chi-squared test says, hey, not independent. All right? So let's look at a couple examples. So if we have the numbers on cards written from 1 through 9, and then we draw cards from the bag, what is the event that an odd number is chosen? Well, there's 1, 3, 5, 7, and 9. What about B? That would be the event that a square number is chosen. So that would be 1, 4, and 9. Okay, we can see that there is overlap there. If we write it in the Venn diagram, we'll have 1 in the middle, we'll have 3, 5, 7, 9. Oops, the 9 is also in the middle, right? Okay, and then B would be 1, 4, and 9. Okay, so let's see. The probability that A would happen times the probability of B would happen, is that the probability that A and B happens? We're going to test that. So the probability that A and B happens is going to be 2, which is that you draw 1 or 9, over the total, which would be 9 possibilities, right? So it would be 2 9s. Now let's see if that's equal to the probability of A happening times the probability of B happening. Probability of A happening would be 1, 2, 3, 4, 5 outcomes out of 9. And the probability of B happening would be 3 outcomes out of 9. Now let's see if multiplying those together we get the same thing. So we get 15 out of 81. And then 15 out of 81, no, that is not the same as 2 9ths, because 2 9ths would be about 18 out of 81. So no. So not independent. Okay? Which means that drawing a square number is dependent on drawing an odd number, or vice versa. Okay, so there's a relationship, a correlation between drawing a square number, drawing an odd number. Okay? All right, now let's do number 3. The numbers 2, 3, 4, 5, 6, 7, 8, 9, 10 are written on cards and placed in a bag. Okay? A would be the event a prime number is chosen. B would be the event a multiple of 3 is chosen. So let's see, a prime number chosen would be 2, 3, 5, 7, and 9. And B would be multiple of 3, which would be 3, 6, and 9. How many outcomes total are there? 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's 9. So we can write these outcomes into the appropriate part of the Venn diagram. Is there any overlap? Yes, there is. There's an overlap with 3, and there's an overlap with 9. So we'll write 3 and 9 here in the middle. And then event B would be 3, 6, 9. Event A would be 2, 3, 5, 7, 9. Okay, so the probability of A times the probability of B. Let's check to see what that is. See if it's equal to the probability of A intersect B. So probability of A is going to be 1, 2, 3, 4, 5 out of 9. Probability of B would be 3 out of 9. And the probability of both happening would be 2 out of 9. So that would be 15 out of 81 on the left side. Is that the same as 2 out of 9? No, because 2 out of 9 is actually 18 out of 81. So again, not independent. Okay? Okay. Now let's go down to number 5. The Venn diagram shows the number of students who take chemistry and or biology. Use the Venn diagram to determine whether taking chemistry and biology are independent events. Okay, so these are the number of students in each section. So let's see, probability of biology intersect chemistry. Is that equal to the probability of biology times the probability of chemistry? Let's see. Well, the probability of biology intersect chemistry would be 8 out of something. What's the total here? It would be 2 plus 8 plus 13. It would be 13. Oops, there's 5 outside too, so that would be 18. 18. Okay, so it would be 18. So 8 out of 18 is equal to probability of B, which would be 11 out of 18. And probability of C would be 10 out of 18. So let's multiply those together and see what we get. We get 110 out of 18 squared. Is that equal to 8 out of 18? Let's see. Doesn't look like it. Okay, if we, let's see, 18 squared, that would be, 18 squared, that would be 324. So this would be 324, and then 8 times 18, that would be 144. Yeah, so you can see they're not equal, so that means no, they are not independent. I only told you to do the odds, but I'm going to go back and do an example where the events are independent so that you can see what that looks like. So we'll do number 2. So if you have number 2, you have event A being you're rolling or you're drawing cards again. You're going from numbers 1 through 6. Okay, so you have 6 cards total. What is the chance that an even number is chosen? Well, that would be 2, 4, and 6. So that would be 3 out of 6. What is the chance that a square number is chosen? That would be 4 and 1. So that would be 2 out of 6. So if you multiply those together, do you get the chance, the same, the probability that a even and square number is chosen? And the only number that is both is 4. So if I multiply 2 6 times 3 6, do I get 1/6? And so let's check that out. 2 times 3 is 6. 6 times 6 is 36. Yeah, 6 out of 36 is 1/6. So we have found an example of an independent event.